Alright, here's the second half of 5.1, 5.1b. The word concurrent, and this is our first term that we're going to need to learn. Concurrent means that three or more lines intersecting at one point. Okay, so over here we have an example of concurrent. Three lines intersecting all at this point, O. And the point of concurrency is simply the point at which three or more lines intersect. That's it. So concurrent means for three or more lines to intersect, and the point of concurrency is just where this happens. Alright. A couple theorems. Theorem 5.6, the perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. So here, check it out. I have a perpendicular bisector, and actually I think this drawing is not that great, but they would all intersect at the same point. Let's go on the next a little bit better. And this point would be called the circumcenter. Theorem 5.7 says the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides. So here we have an angle, bisector, angle, bisector, angle, bisector, and they're all concurrent at this one point that is equidistant from the sides. This point is called the incenter. And we talked about this before, but that's because these 2 points make circles, either inscribed or circumscribed around the triangle. Not something we're going to spend a lot of time on, but this stuff is where it gets. This is stuff that you're definitely going to want to know. Okay, the median of a triangle. This is a segment extending from the vertex. Vertex just means a corner. Man, my pen's not working. From a corner to the midpoint of the opposite side. Okay, so we have a drawing here, and I think we even have some drawings over here. See, we have, it comes from one corner and it goes to the midpoint. Corner to the midpoint, corner to the midpoint, and so on and so on. And so this point where all the midpoints connect, because just this is what theorem 5.8 says, the medians of a triangle are concurrent at a point that is 2/3, that's important, we'll come back to that, the distance from each vertex to the midpoint of the opposite side. And this point of concurrency is called the centroid. And that is because the centroid will always be the exact center of gravity of the triangle. It'll be like right there in the center. And like I said, it is 2/3 the distance from each vertex to the midpoint of the opposite side. So once we got these things drawn out, we get some cool information. Here's my centroid. It's right in the center. It's all my medians connected. This distance is going to be 2/3 the whole distance, and this is going to be 1/3 the whole distance. So 2/3, 1/3, 2/3, 1/3, all the same. This is going to help us. We're going to do some problems with this, because if I know something about this distance, I should be able to find this distance. And if this is 2/3, that means that it's twice as big as 1/3. So we'll do some problems with that. Okay. For example, it says, if the distance of FG is 5, what is the distance of GC? Okay, so let's zoom in here and mark some stuff down. Alright. It said that FG was 5. Let's put a little 5 here. And we're supposed to figure out what GC is. Well, think about it. If this is the 2/3 part, and this is the 1/3 part, and 1/3 is 5, that means that 2/3 is 10. And there we found GC. So I could go down here, and I could say that GC must be 10. Okay. Alright, well, let's erase that, and let's give it a little bit tougher question now. Okay, let me get rid of all that. Okay, and now the tougher question is, if the distance of GE is x plus 2, and the distance of BE is 21, find x. Okay, let's zoom into our picture again. Remember that GE is x plus 2. Okay, so this is x plus 2. But then they told me that this whole distance is 21. Alright, well, if this whole thing is 21, I need to figure out what 2/3 of 21 is and what 1/3 of 21 is. And hopefully some of you guys will recognize right away, well, 1/3 of 21 is 7. And 2/3 of 21 is 14. So if we're trying to solve for x, we know that GE here is 7 and it's x plus 2. So I'm going to say that 7 equals x plus 2. Subtract 2, and I get x equals 5. So we come down here. If the distance of GE is x plus 2, and the distance of BE is 21, find x. Well, we just found it. We said that x equals 5. By the way, sorry about my voice. I'm like losing it, but still trying to make these videos for you guys. Okay. Here. Well, now let's talk about the altitude. And before I tell you anything about the altitude, any definition, I want you guys to remember that you've probably learned about this before, you probably just didn't call it the altitude. It's actually called the height. That's another word for it, and it's a more common word for it actually in lower math that you've probably seen. But you'll probably see it referred to as the altitude from now on, so just know it's really the same thing. Okay. The altitude is the perpendicular segment from a vertex to the line containing the opposite side. The reason why we say the line containing the opposite side is because the altitude is not always inside the triangle. So here's a triangle. Actually, that's a bad example. Let's draw a different triangle. Okay, here's a better triangle. And if I wanted to draw the altitude for this thing, let's say the altitude from this side to the top, well, I would have to kind of extend this line here. And then I could draw the altitude. Let me zoom in. Because this top part of the triangle has to be at a right angle to the bottom. That's what makes it an altitude, is that it's at a right angle from the opposite side. Now here's an altitude, and look, it's outside the triangle. But that's just sometimes. A lot of times it's inside the triangle like we see here. You see this line is at a right angle to QP at point G, and this is a right angle of PR, and this one's a right angle of QR, and goes up to P. So those are all altitudes. And the lines that contain the altitudes of a triangle are, guess what? They're concurrent. And the point at which these lines containing the altitudes of a triangle are concurrent is called the orthocenter. Okay. Now, to save a little bit of time, I went ahead and graphed these points. So the coordinates of triangle JKL are J13, K2 -1, and L -1, 0. And we're supposed to find the coordinates of the orthocenter. Okay, remember, orthocenter has to do with altitudes, which means that we need to find the altitudes of all these triangles. Well, that's a little bit tricky. I'm going to show you how to find the altitude of one side, and then I'll let you guys try and find the rest. The basic idea here is we need to find the slope of this line, and then find the perpendicular slope of this line so that we could figure out which direction that altitude is supposed to go off. Well, remember that slope is simply rise over run. Okay, so the slope of JL, so the normal slope of JL has a rise of, let's see, well, it starts down here at 0 and it goes all the way up to 3. I made all mine, by the way, if you couldn't tell by the graph. I made every every 2 boxes worth 1, just so that my triangle could be a little bit bigger. So yeah, I start at 0 and I go up to 3. Okay, so that means I have a rise of 3. And then what's my run? Well, I start at -1, and I'm going all the way over to +1, right? -1 to +1. So that means I went over 2 units. So there's my slope. So in order to find the perpendicular slope to JL, we just take those two numbers, we flip them, and we slap a negative in front, because it's the opposite reciprocal. And remember that this guy has to go, this altitude has to connect at this line and then connect to this point. So I'm actually going to start at this point and go backwards. So I'm going to go, well, this is also important. Remember that -2/3 is the same thing as 2 over -3. Because if I wanted to, I could go down 2 over 3, but that doesn't really help me. I'm not going to get to my other point here. So let's instead go up 2, back 3. Up 2, back 3. And now we can see that I am able to find my altitude. And that is going to be at an exact right angle to JL. Now, what you guys have to be able to do is do that for all of these sides. And then you'll see that all of these altitudes meet up at a point, and I'll let you know it's going to be somewhere right around here. And yeah, see if you can't find the altitude graphically. And I went ahead and worked it out, and it is a fraction. It's kind of a weird fraction, so don't worry about finding the exact number, but just worry about being able to graph it at the right spot for now. I think that'll be really helpful for you. Okay, so give that one a try. I'm going to go ahead and maybe I'll just pause the video and let you guys finish that out, and then I'll have all the rest of the work up there for you. Okay, so I went ahead and drew in all these altitudes here, and we can see, let me zoom in, you can see where they all line up right here, right at that point. And that's all I want you guys to be able to do. If you were having some trouble calculating the slopes, I got the JK slope was -4/1, so the perpendicular slope would be 1/4, or 1/4, and LK, the slope was -1/3, so the perpendicular slope would be 3. Okay, let's go on to the very last problem. Alright, so on example number 3 here, I already went ahead and solved for x for you guys. And all I did is I said, hey, look, this is the 1/3 part, and this is the 2/3 part. So I need you guys to, what you got to do is you got to figure out, well, if this is 2/3 and it's 6, that means that this 1/3 part would be half of 6, so it would be 3. So I set it equal, did some algebra, and I solved for x. I got x equals 4. You're going to do the same logic with the y and with the z. So y here is the 2/3 part, 2.9 is the 1/3, 4z is the 1/3 part, and 4.6 is the 2/3. So I would recommend that you figure out what each of these little sections are first, set it equal, and then solve. I'm going to have you guys pause the video, try that on your own, and then I'll have the answers up there in just a little bit. Alright, so here's those problems. I worked them out for you. Here's the answers. So check your work. Make sure you guys got the same thing. You can see how I set it up. I said 4z equals 4.6 divided by 2 because I knew this was the 2/3 part, so I had to cut it in half. And here I said y equals 2 times 2.9 because I knew this is the 1/3 part, so I had to double it. So check your work. Make sure you get the same thing. Good luck.